Hi everyone, I'm going to lead you through this task, which I'm going to count as a lab. If you were in a face-to-face course, we would do this together, where I would do some with you in class, and then you would go home and finish them, and then we would come to the next part, you would go home and finish them, and so forth. So if you're watching this video, it's probably because you are in an online class, or I've decided to do this task online. By the way, I'm in a part of my house where I have my cats. So if one jumps into our field of vision, please excuse me, but that's the way it goes. I've got two of them right here next to me. Okay, so the other thing is because of the way this paper is laid out, I hope this shows up properly on your video. If not, I would ask you to rotate your device and go with the flow on it. Okay, so you should have this handout, and I'm going to call this VSEPR or Lewis structures. VSEPR, Lewis structures, net dipoles, or something like that. Okay, so you need to have that. All right, so don't do this until you've watched the videos that I've given you, plus the ones that I've linked, because I'm not going to reinvent the wheel. Okay, so the first thing you're going to do is make your skeletal structure. And the videos will tell you to count valence electrons, choose a central atom, bond, and then assign the bonding electrons or the remaining electrons from there. So I'm going to pick out a couple and do them for you, and then your task will be to pause the video and complete the next. Okay, so we're going to do this first. Okay, CH4, we'll have carbon in the middle. Okay, 4 plus 4 is 8 electrons, 2, 4, 6, 8, so this one is done. CH4O, I'm just going to pick and choose. 4 plus 4 plus 6 gives us 14 electrons. Carbon is king. Hydrogen, 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 oxygen, hydrogen. 2, 4, 6, 8, 10 means I have 4 electrons remaining. The only place they can go are on the oxygen. Okay? Plus charge, we always lose an electron to get a plus charge. So we have 3 for the hydrogen, 6 for the oxygen, minus 8 gives us, minus 1 gives us 8. Oxygen in the middle, hydrogen, hydrogen, hydrogen gives us 2, 4, 6. 2 electrons remaining means they go over here, and this whole thing has a positive charge. Okay? Now your job is to complete all 6 pages. So there's page 1, page 2. You can skip that one. Page 3. Okay, this has a minus charge, so let's try that one together. 5 for the nitrogen, plus 2 times 6 is 12, plus 1 more for the negative charge gives us 80 electrons. Okay, nitrogen in the middle, oxygen, oxygen, that's 4 electrons that are bonding. So we have 14 remaining. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is what students will normally do. And you see that this nitrogen here has only 2, 4, 6 electrons. So we're going to double bond. 1, 2, 3, 4, 5, 6. Double bond. 1, 2, 3, 4. Okay, and then this whole structure is going to have a minus or minus 1 charge. Now there is something called resonance. Resonance means the electrons that move, so I don't have to double bond here, I can double bond here. And so what I would end up with then is my double bond on the other side. Minus 1 charge. Okay? By the way, this one's going to be an exception. Okay? All right, let's go to the next page. Let's come down here to this one. Okay, our rules are going to say that we're going to link our carbons together. 3 hydrogens, 1, 2, 3. Hydrogen, hydrogen, hydrogen. Chlorine, chlorine, chlorine. Okay? And then you're going to have some lone pairs out here. All right, now in this instance, we can move some of these chlorines around. So now we don't have resonance, we have what we call isomers. Okay, isomers. Because we're not moving electrons, we're moving atoms. So for example, we could end up with something like this. Chlorine, chlorine, and move a chlorine over here. 1, 2, 3 hydrogens. And so this is a huge topic with carbons and carbon chemistry, and you would see that, a lot of that, in a biochem course, which is what you're going to do next. Okay? On this page, we're going to get some expanded octets. Okay, some expanded octets. So this one's going to be expanded, 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 expanded. So let me start with this one. I think this one will be in your field of view. All right, so sulfur is 6, fluorine is 7 times 6 is 42, so we have 48 electrons. Sulfur in the middle, 1, 2, 3, 4, 5, 6. It is counterintuitive for students to do that, but if you don't put 6 around your sulfur, you'll never get it to work. You've used up 12, you have 36 electrons remaining and 6 fluorines. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and so forth. So this then becomes our valid Lewis structure. Okay? All right, so your job is to complete all of the Lewis structures on this page as, well, on the handout. Okay, so this is your first task, and that's going to count for lab points. Okay? Now, from there, what you have to do is count areas of electron density on the central atom. And we should have done that in the lecture notes. So I'm going to choose the ones that I've done already. Okay, so over here, we have 4 areas of electron density, which means our electron geometry is going to be tetrahedral. And we have 4 atoms binding, so we're going to have tetrahedral molecular geometry. Okay? Over here, I want to focus on the oxygen. We have 1, 2, 3, 4 areas of electron density on that oxygen. So the electrons are going to form a tetrahedron. Okay? But the molecule itself, okay, I happen to have something that makes a good model right here in front of me. 2 things that are bound to the oxygen, but 2 lone pairs. And so what that means is that the shape of your molecule, even though the electrons are forming a tetrahedron, your molecule is bent. Okay, bent. So I'm going to leave some space because if I say that this is bent, I want to make it bent in my drawing. Okay. Over here, our oxygen has 1, 2, 3, 4 on the central atom, so the electrons are also tetrahedral, just like this, except our oxygen in the middle has 3 atoms bound and 1 lone pair. So again, your lecture notes and the videos and your book all explain this, so if I have models handy, I will use them. Okay, so here's basically how this will look. This is a lone pair. So what we end up with, this is the molecule that we have remaining, and this is what we call trigonal pyramid. So if I say it's a pyramid, I should draw it as a pyramid. Okay, so So I'm going to draw it as a pyramid. The oxygen is here, and I'm going to exaggerate the parts of the pyramid that point down. And the reason for this is you need the molecular shape to help you with the rest of this. Okay, so your second task is to complete all 6 pages of all of these structures. Okay, all of these structures. Here our electron geometry 1, 2, 3 is going to be trigonal planar. Our molecular geometry, because we have a lone pair, means that it's going to be bent. Bent. Okay, so your job is to go through the entirety of this handout. There's 6 pages of it. Depending on how things unfold, I may have you work in teams or in groups because this is a lot to do. Okay, so we're going to stop the video here, and your job, again, is to complete this column, then that column.